Quick test. Statistically, and I mean this in the way a physicist would mean it, you might have come into existence 5 seconds ago, with all your memories preloaded, including the memory of clicking on this video. Try to disprove that. I'll wait. This is the Boltzmann brain. Vienna, 1895. Ludwig Boltzmann is having a bad year. He has a theory of why entropy goes up. Hot things cool down, gas spreads out, things get messy. Then a guy named Schmidt heckles him. Schmidt says, but wait, the laws of physics work the same forwards and backwards, so why does entropy only go up? Boltzmann panics a little. He writes a letter to nature, December 1895. Floats an idea. The whole observable universe, everything you see, might be a giant statistical fluctuation in an otherwise dead, high-entropy soup. Boltzmann was so uncomfortable with this idea that he attributed it to, quote, his old assistant, Dr. Schutz, end quote. He blamed it on his assistant. Classic. Here's the equation Boltzmann is famous for. It is engraved on his tombstone in Vienna. He died before he wrote it down in this exact form. Statistically, that was unlikely. Now, the fluctuation lottery. Imagine an infinite universe of dead high-entropy gas. Cold, uniform, boring, but not perfectly uniform. There is always thermal noise. Particles bouncing. Wait long enough, and we are talking incomprehensibly long, and any configuration eventually shows up, just by chance, including configurations that look exactly like a galaxy, or a star, or a planet, or a stick man explaining it, or a brain, with memories, like yours, right now. Here is the punchline. A brain with your exact memories has roughly 10 to the 42nd power units of information. That is a 1 followed by 42 zeros. The whole observable universe has roughly 10 to the 104th power units. A 1 followed by 104 zeros. That is the entire universe. Stars, galaxies, cosmic background radiation, everything. Now the question. Which is more likely to randomly appear from a fluctuation? A brain or a whole universe? The answer comes from this formula. The probability of fluctuating something is exponentially suppressed by its entropy. The formula looks like this. Plug the numbers in. The ratio of brain fluctuation to universe fluctuation is e to the power of, and I am not making this up, 10 to the 104th. Translation. A fluctuation just big enough to make your brain, with all your memories, is unspeakably more likely than the fluctuation needed to produce the entire visible universe, by a factor of e to the 10 to the 104th. So here is where Boltzmann's idea becomes a horror story. If observers come from random fluctuations, almost all observers are disembodied brains, floating in a void, existing for a moment, then nothing. And it gets worse. In 2017, Carroll wrote a paper titled, quote, Why Boltzmann Brains Are Bad, end quote. He calls these scenarios cognitively unstable. Cognitively unstable means the theory cannot be true and justifiably believed at the same time. Watch. If most observers with your memories are Boltzmann brains, then probably you are one. Then probably your reasoning is the product of a random fluctuation. Then your reasoning is unreliable. Then you cannot trust the conclusion that you are probably a Boltzmann brain. It is the only scientific theory that cancels its own subscription, and in modern cosmology has this exact problem. Step 1986, André Linde at Stanford proposes eternal inflation. The Big Bang never really stops. New universes keep budding off forever. It is the multiverse, mathematically. Eternal inflation runs forever. Forever is a long time. Long enough that, in some natural measures, Boltzmann brains end up massively outnumbering ordinary observers like you. The multiverse is allegedly drowning in disembodied brains. Don Page at the University of Alberta wrote a paper in 2008. The title is, and I am not making this up, Is Our Universe Likely to Decay Within 20 Billion Years? His argument, the universe had better decay before Boltzmann brains take over. Otherwise, we have to throw out modern cosmology. He is rooting for the apocalypse. On a deadline. Cosmologists now use Boltzmann brain reasoning as a filter. Theories that predict too many of you get rejected. Like a bouncer at a club, but for cosmologies, pump the brakes. Honesty time. What the math actually says. The argument depends on 3 big assumptions. 1. You are a typical observer. 2. The universe lasts long enough for fluctuations to dominate. 3. The vacuum is really, truly, eternally stable. In 2015, Boddy, Carroll, and Pollock made a different argument. A truly quiescent vacuum has nothing measuring it. No measurement, no fluctuation. Brains never actually pop into existence. The math was being too optimistic. The same year, Don Page wrote, quote, "Bayes keeps Boltzmann brains at bay," end quote. He is annoyingly literal. Argument. Conditioning on what you actually observe, a coherent past, a body, a video player, pulls the math back toward ordinary observer. You exist too coherently to be a Boltzmann brain. Suspicious. Roger Penrose has a favorite number on this. The initial entropy of the observable universe was 1 part in 10 to the power of 10 to the 123rd. That is a number with 2 stories. A penthouse on top of a penthouse. So, here is where we are. The Boltzmann brain isn't a result. It's a failure mode. A way that a class of cosmological theories collapses under its own assumptions. The fact that physicists take it seriously is itself the unsettling part. Boltzmann himself never wrote down the brain version. He blamed the fluctuation idea on his assistant. He died in 1906. Statistically, that was unlikely. Whatever you think you are, you probably are. The math saying otherwise has a bug. The bug is the math. The math knows it. If you are a Boltzmann brain, this video ends in about a second. When your brain disperses back into the vacuum, probably fine.